In this lesson, we'll review graphing trigonometric functions. So we're asked to graph the function f of x equals 3 cosine of x plus 2. So what we'll notice here is that if we can first graph our function y equals cosine of x, then we can apply what we know about transformations of functions to graph 3 cosine of x plus 2. So let's think about how we graph the function y equals cosine of x. So this is a function that you should know how to graph, but let's review how we obtain the graph from our unit circle. So remember, cosine, that means the x coordinate on our unit circle. So when x is equal to 0, what is the cosine of 0? Well, we find the angle 0 on our unit circle. The x coordinate is 1, so that gives us the point 0, 1 on the graph of our function. So when x is 0, cosine of 0 is equal to 1. What happens next? Well, another important point, when our angle is pi over 2, so when x is pi over 2, cosine of pi over 2, the x-coordinate there is 0, so our graph crosses the axis at pi over 2, 0. And we see that the x-coordinates are just decreasing, so getting smaller, as our angle ranges from 0 down to pi over 2. Now what happens at pi? So when our angle is pi, the x-coordinate is -1, so we have this minimum value down at x equals pi. Cosine of pi is -1. And then at 3 pi over 2, the x-coordinate is 0. So we come back up to 0. And then when we get all the way back around to 0, or 2 pi, we are back up at an x-coordinate of 1. And so this function is what we call periodic. It just keeps repeating this pattern. It repeats to the left as well. So if we do negative pi over 2, remember what that means is go negative 90 degrees. So 90 degrees in the other direction, which just puts us down at 3 pi over 2. The x-coordinate here is 0. So at minus pi over 2, again, we're at 0. So here's our graph of y equals cosine of x. Again, you should know the graph of this function. You can obtain it from your unit circle, but it's a graph that you should know. So it has an amplitude, what we call an amplitude of 1. So it goes down to -1 and up to 1. So the amplitude of this is 1. It has a period of 2 pi. So it repeats every 2 pi units. So let's think now about how to graph our function f of x equals 3 cosine x plus 2. So the first thing we'll do is just graph y equals 3 cosine of x. So to do that, we'll take our previous graph, our general graph of cosine of x, and if I want to do 3 times that, I'm just multiplying all of the y coordinates by 3. So instead of going down to -1 and up to 1, I'll go down to -3 and up to 3. So I've just scaled our graph by a factor of 3. So all of my y coordinates are getting multiplied by 3. So I go down to -3 and up to 3. And then what is the 3 cosine of x plus 2? Well, I just shift everything up by 2 units. So remember, previously we went from -3 to 3. When we add 2, we're just shifting up 2 units. So we'll go, instead of -3 to 3, we'll go -1 to 5. And so we can pick out particular points. So for example, when x is equal to 0, cosine of 0 we know is 1 from our unit circle. 3 times that is 3, plus 2 is 5, so we have our point 0, 5. What about, let's say, pi over 2? So cosine of pi over 2 we know is 0. 3 times 0 is 0, plus 2 gives us the point pi over 2, 2, etc. You can find all of the important points on our function by plugging in as well. So when x is equal to pi, cosine of pi is -1. We multiply that by 3, we get -3, plus 2 gives us -1. So we did this in a series of steps. So we started with our function y equals cosine of x, so our standard cosine function. We then multiplied all the y values by 3, and from there we shifted up 2 units. So here now I've graphed all 3 of our functions on the same set of axes. So you can see the shifted one, so the red one here is our 3 cosine of x plus 2. The green graph is just our standard graph that goes -1 to 1, that's our cosine of x. And then the blue one is the cosine of x scaled by a factor of 3, so it goes from -3 to 3. And again, what you want to focus on here is that you should know how to graph your standard trig functions, so cosine of x, sine of x, tangent of x, and you can always do that using your unit circle, and from there you should be able to apply transformations, so what we know about functions, to obtain transformed versions of those standard graphs.